Hi, my name is Sudhir Bandar and my student ID is 10504163. This video demonstration is about Internet Protocol which focuses on the IP datagram. Internet Protocol is the principal set of digital message formats and rules for exchanging messages between computers across a single network or a series of interconnected networks using the Internet Protocol suite. Messages are exchanged as datagrams, also known as data packets or just packets. The main purpose and task of IP is the delivery of datagrams from one source, that means source computer, to the destination or receiving computer based on the addresses. And what is actually a trace route? A trace route is a function which traces the path from one network to another. It allows us to diagnose the source of many problems. A traceroute command sends ICMP packets to test connections and report on latency between 2 points of the internet. It can be used to help diagnose networking errors and is accessible by using the traceroute command or by using the further developed software like ping plotter. So let's investigate the IP protocol focusing on the IP datagram. Let's do so by analyzing a trace of IP datagrams sent and received by an execution of the traceroute program. And ping plotter is actually a nice Windows traceroute program. So let's focus on just three seconds here, so we don't have to deal with much data. Let's use the new trace as this domain, and we can just resume these and we can just change the packet size to 2000. Give OK and resume. You can see, and we can just resume again and change the packet size to 3500, and let's see. Okay, let's pause this and let's check this on Wireshark now. Well, according to the results, you can see that the IP address of my computer is 192.168.1.102. Within the IP packet header, the value in the upper layer protocol field is ICMP1. You can see that when data is sent over the internet, each unit transmitted includes both header information and the actual data being sent. The header identifies the source and the destination of the packet, while the actual data is referred to as the payload. Because header information or the overhead data is only used in the transmission process, it is stripped from the packet when it reaches its destination. Therefore, the payload is the only data received by the destination system. According to this record, the header length is 20 bytes here, and the total length is 84 bytes. Therefore, the payload of the IP datagram should be 60 bytes, which is 84 minus 20 bytes. And IP fragmentation occurs when an IP datagram traverses a network which has a maximum transmission unit that is smaller than the size of the datagram. According to this IP datagram, it is clear that this IP datagram has not been fragmented, as we can see that the more fragments bit equals to 0. We will see these later when transmit longer ICMP echo requests. So let's check what fields always change from one datagram to the next, which within this series of ICMP messages sent by my computer. We can can observe that can observe the identification changes here. The identification time to live and the header checksum in the IP datagram always change. Identification changes because the IP packets have different IDs. Time to live changes because the trace route increments each packet, and header checksum changes because the header changes. The fields that remain constant are the header length, because it doesn't change since we are always using. The source IP is always my IP address of the computer, and destination IP, it also does not change. And differentiated services are the same protocol every time. Differentiated services, same protocol every time. And upper layer protocol, same protocol every time. And header checksum, validation disabled in my case. You can see a pattern in the identification field of the IP datagram here, and it increments by 1. Time to live, TTL, is a value in an IP packet that tells a network router whether or not the packet has been in the network too long and should be discarded. An IP TTL is set initially by the system sending the packet. It can be set to any value between 1 and 255. Different operating systems set different defaults. Each router that receives the packet subtracts at least 1 from the count. If the count remains greater than 0, the router forwards the packet, otherwise it discards it and sends an ICMP message back to the originating host, which may trigger a reset. So in the datagram, the identification field has here the identification field has a value of 4316, and the TTL is 255. The values of the identification field changes for all the ICMP TTL exceeded replies, since the identification field is a unique value. If 2 or more IP datagrams have these same identification value, then it means that these IP datagrams are fragments of a single large IP datagram. When I change the packet size in pin plotter to be 2000, the message has been fragmented across more than one IP datagram. We can confirm it by looking at the identification number and info field. So we can check that here. Here we go. The identification number here is 13049, and it's the same here, 13049. Now let's see the first fragment of the fragmented IP datagram. The information in the IP header indicates that the datagram has been fragmented. Here, the flags bit for more fragments is set to 1, which means the datagram has been fragmented. The fragmented offset is 0. Offset is 0 here. And the length of this first datagram is 1500, including the header. Now let's see the second fragment of the fragmented IP datagram, which is this. Let's see what information in the IP header indicates that this is not the first datagram fragment. According to this datagram, this is not the first fragment, since the fragment offset is, it is 185 here, and this should be the last fragment since the status of more fragments flag is not set. It is noticeable that the total length flags fragment offset and check some change in the IP header between the first and the second fragment. These and these, of course. Fragment offset and checksum fields change in the IP header among the fragments. Thank you very much.